ಇಲ್ಲ ನಾವು ಕ್ವಶನ್ಸ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಡೈರೆಕ್ಟ್ ಕ್ವಶನ್ಸ್ ಚೆನ್ನಾಗಿದೆಯಾ? ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಟು ಎವ್ರಿಬಡಿ. ಎಷ್ಟು ಜನ ಇದ್ದಾರೆ ನೋಡಿ. ಹನ್ನೊಂದು. ಏನು ವೇಟ್ ಮಾಡೋಣವಾ ಹೇಗೆ? ಆಯ್ತು, ಕರೆಕ್ಟಾಗಿ ಆನ್ ಟೈಮು ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ ಬಿಡಿ. ಡೌನ್ ಮಾಡಿ. ಯಾಕೆ ಆನ್ ಟೈಮ್ ಬರಲ್ಲ ಹುಡುಗರು? Okay, good morning to everybody. Well, I will start and let us not wait for the others to come. Okay, so I wish all of you will join the class on time whenever the class is there. All right, the next question is in a reverse bias. So continuing the solid state electronics, I have given the synopsis in detail. Yesterday also I gave a brief synopsis, so only a few more questions have been left. So therefore I don't want to mention the synopsis again. All right, so the next question is in a reverse bias, the diode, when the applied voltage changes by 1 volt, the current is found to change by 0.5 microampere. The reverse bias resistance of the diode is, well, so voltage has been given and the current has been given, and he is asking you to calculate the resistance. V is equal to IR. There's a basic formula. Well, so therefore this implies R is equal to V by I. This is 1 by 0.5 to 10 power minus 6. Well, 1 by 5, that is same as 1 by 2. 1 by 2 is that 2 goes to numerator, 2 into 10 to the power plus 6 ohm. Okay. Well, the next one, in a common emitter, so 2 into 10 power plus 6, that is this one, fourth one. In a common emitter amplifier, the input signal is applied across, well, always the input signal, that will be applied across the base emitter junction, that's the input region. Okay, this is the input region, base emitter junction. Anywhere not true, emitter collector is not true, collector base is also not true. This is the output region. Well, the next one, the half-wave rectifier is being used to rectify alternating voltage of frequency 50 Hz. The number of pulses of rectified current obtained in 1 second is 50 Hz means 50 cycles per second. In 1 second, 50 cycles will be passing through the circuit. Okay. Well, so the number of pulses rectified current obtained in 1 second. So this is 1 pulse. This is 2 pulses. Okay. Well, what is half-wave rectifier? That is one of the types of the rectifier in which AC will be converted into DC during only half cycle of AC. Well, so during the positive half cycle, current will be, the signal will be converted into the DC. Well, and the next half cycle, the diode D becomes a reverse bias, and in the reverse bias, there is no current through the load resistor, so therefore there is no current. Okay, next, once again in the next option, so when the positive pulse appears at the end, well, negative pulse appears at the other end of the transformer, secondary transformer, and the diode D becomes a forward bias and current flows. Again in the reverse bias, that is when the the negative pulse appears at the end, the diode becomes a reverse bias and there is no current flow. Look at this. So for 2 cycles, 2 pulses will be there, and for 50 cycles, so 50 pulses will be there. And in case of so full wave rectifier, in case of full wave rectifier, how many pulses will be there? That is in both the half cycles, AC will be converted into DC. Even in this also, well, so when a negative pulse appears at the end A, positive pulse appears at the end B, and the diode D2 becomes the forward bias and it conducts and it becomes 100 for the full wave rectifier. All right, what is the voltage gain in a common emitter amplifier when the input resistance is what is the voltage gain in a common emitter amplifier? The input resistance is 3 ohm and the load resistance is 24 ohm and beta is equal to 60. The voltage gain during the synopsis, I gave, so AV voltage gain that is equal to beta into RL by RI. That is equal to beta is 60. Beta usually that varies between 50 to 150 also. Okay. Into RL, the load resistance, well, the load resistance is 24 and the input resistance, that is equal to 3 ohm. That is equal to 8 8 4 so 8 6 4 48, that's a 480 ohm. Well, 480, well, it's been wrongly printed. This is 408. This is not the one, that is 480. Please kindly change it to 480. Well, the next one, in case of a semiconductor, which of the statement is wrong? So you have to identify the wrong statement. Doping increases conductivity. That's the right statement only. Temperature coefficient is the negative. That is also true. In case of metals, TCR, that is equal to positive. This is for the conductor. That means as the temperature increases, resistance also increases. That's all the TCR positive. Well, TCR is equal to negative in case of the semiconductor. Okay, resistivity, that is also true. Resistivity is in between conductor and an insulator. This is also true. At 0 Kelvin, it behaves like a conductor. This is not true. Well, at 0 Kelvin, it is an insulator. So this is the wrong statement. So this is the right answer. Because he is asked us to calculate so identify the wrong statement. The next one, for a transistor, the parameter beta is equal to 99, the value of the parameter alpha. Well, alpha and beta have been related with this. Alpha is equal to beta by 1 plus beta. Obviously, well, this is 99 and this is 100, and so that is less than 1. Okay, the ratio. This is 99 by 1 plus 99. That is equal to 99 by 100. Decimal will be shifted by 2 digits. That is 0.99. Always alpha will be less than 1. This you should remember. Beta value generally it varies between, it depends on the transistor, that is 50 to even 200 also. Well, so next we shall switch over to the next chapter. This is a photoelectric effect. Well, under the photoelectric effect, let me just give the synopsis for some time and then we should start the questions. Thereby, most of the questions, as we have discussed today, solid state electronics, most of the questions, that you can so answer yourself once you listen to the synopsis, the detailed synopsis. ಚೆಕ್ ಮಾಡಿ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ಗೆ. Okay. So, what What is photoelectric effect? The metals will have large number of free electrons in it. What are free electrons? The electrons which are not confined to any orbit, any atom, free to move anywhere in the given metal or the crystal, and they are totally responsible for the conduction of electricity, is called the free electrons. For example, if you take sodium atom, its atomic number is 11 and its electronic configuration is 281, which means in the first orbit, 2 electrons will be there, second orbit, 8, and the last orbit, 1 electron will be there. This electron has been loosely bound to the nucleus of the atom, and since it is far away from the nucleus, if you supply external energy to this electron, well, the electron absorbs the energy and overcomes the electrostatic force of attraction between the electron and the nucleus, and finally electron could be removed to a distance of infinite with respect to the nucleus. Once electron has been removed to a distance of infinite with respect to the nucleus, infinite means the effect of the nucleus is just vanishing at that point. That point is called the point of infinity. Once electron has been removed to a distance of infinite with respect to the nucleus, this electron never comes back to the orbit, never comes back to the atom. That is free to move anywhere in the given metal or the crystal, and this electron is totally responsible for the conduction of electricity. That electron is called free electron. And whatever the thermal energy available at room temperature, that is more than sufficient to knock out this electron completely from the orbit of the atom. So therefore, out of one sodium atom, we have got one sodium ion and free electron. This we are not really interested. Well, one free electron we got. Similar, if you have n sodium atoms, you will have n number of free electrons. Okay. Not only sodium metal, all metals at room temperature will have innumerable number of free electrons and innumerable number of positive ions. Okay. Metals will have large number of free electrons in it. Okay. Well, when you supply external energy, well, the free electrons absorb the energy, overcomes the surface force. The electron, what is the surface force? Electrons will be held back by the metal with a force called the surface force. And finally, electrons will be ejected or emitted from the surface of the metal. When you supply external energy to the metal, the free electrons present in the metal absorb the energy, overcome the surface force, and finally electrons are ejected or emitted from the surface of the metal. Well, this phenomenon is called the photoelectric effect. What is so? This phenomenon is well, this is the emission of electrons. Depending on the nature of the supplied energy, well, the emission process will be named after the supplied energy. When light having suitable frequency incident on a metal, the free electrons present in the metal absorb the light energy, overcome the surface force, and finally electrons are ejected or emitted from the surface of the metal. This phenomenon is called the photoelectric effect. The phenomenon of emission of electrons from the surface of a metal with the absorption of light or photons and suitable frequencies called the photoelectric effect. The emitted electrons, they are called photoelectrons. The motion of these electrons gives rise to current called the photoelectric current. Okay. And examples for the photometals are all alkali metals, sodium, potassium, magnesium, etc. Soft metals. Okay. Well, and if you supply thermal energy to the metal, the electrons are ejected from the free electrons present in the metal, absorb the thermal energy, then the electrons are ejected, then that type of emission is called fermionic emission. Similarly, if you supply electrical energy to the metal, the free electrons present in the metal absorb the electrical energy and the finally electrons are ejected. That is called the electric emission. So, depending on the nature of the supplied energy, emission process will be named after the supplied energy. Well, like the bioenergy, chemi emission, bio emission, turbo emission, nuclear emission, and so on. Okay, there are various types of the emission of electrons will be there. There are various methods with which the electrons could be ejected or emitted from the surface of the metal. Depending on the nature of this supplied energy, the emission process will be named after the supplied energy. All right, the photoelectric effect. Well, now what is what is a simple experiment with which you can conduct we can confirm the photoelectric effect? That is as follows. Experiment. It consists of a photocathode. Well, photocathode is made up of some photometals such as sodium, potassium, magnesium. It consists of a photocathode and an anode. Both of them, they are enclosed in an evacuated glass tube. This is the glass tube. The glass tube is a evacuated glass tube. That's a vacuum filled. This is a side tube with the window quads. Well, now this is the anode, ordinary metal. The cathode has been connected to positive, so the negative of a battery, and the anode has been connected to the positive of the battery. Okay. This has been connected to negative of the battery, anode has been connected to positive of the battery like this. Okay, this is the experiment. When light and suitable frequency incident at the photocathode, photoelectric effect takes place. That means emission of electrons takes place. Okay, these emitted electrons, they are made to move toward the anode by applying the potential, high potential, so across the cathode and the anode. If you apply a high potential, so whatever the electrons emitted by the cathode, they will be driven toward the anode, and finally they reaches the anode and so flows in the external circuit, giving rise to current called the photoelectric current. The photoelectric current, that has been measured using the ammeter, milliammeter. All right. Okay. Well, so this is the experiment. Some observations can be made from this experiment. What are those observations? That is as follows. The first one, the photoelectric effect is an instantaneous one. That means as long as the instantaneous one. That means how long the light incident at the cathode, so long the electrons are ejected or emitted. That means photoelectric effect takes place. Once the incident photons have been stopped, then the emission of electrons also will be stopped at once. So the photoelectric effect is an instantaneous one. Number two, for every photometal, there is a minimum frequency. So below which the photoelectric effect does not take place, above which the photoelectric effect takes place, and that minimum frequency is called the threshold frequency. Threshold frequency denoted by nu naught. Okay, so the minimum frequency above which the photoelectric effect takes place, below which the metal will not respond, that minimum frequency is called the threshold frequency. The minimum frequency of the photons for which the photometal responds is called the threshold frequency denoted by nu naught. Number three, well, the photoelectric current, depends on if more number of photons incident at the photocathode, more number of electrons are emitted, thereby the photoelectric current also becomes more. The number of photons incident per second, is called the intensity of light. The number of photons incident at the cathode is called the intensity. More the intensity, more number of photons will incident, more number of electrons are emitted, and more will be the current in the external circuit. The strength of photoelectric current is directly proportional to the intensity. Well, when you plot a graph of the strength of photoelectric current, there's a very important one, the strength of photoelectric current versus intensity. Well, you get the following variation. As the intensity increases, well, the strength of photoelectric current also increases. Well, beyond the threshold frequency, all of you should remember, only for a particular frequency and onwards, below that frequency, that means when frequency of the incident light is less than the threshold frequency, the photoelectric effect does not take place. Only if the frequency is greater than or equal to the threshold frequency, then only the photoelectric effect takes place. In terms of the wavelength, well, so in terms of the wavelength, if the wavelength is very much less than the threshold, if the wavelength is less than equal to the threshold wavelength, then only the photoelectric effect takes place. If the wavelength is greater than the threshold wavelength, then the photoelectric effect does not take place, because the energy and the wavelength, they are reciprocal. E is equal to h, that is also equal to hc by lambda. All right. So the third one is the strength of photoelectric current is directly proportional to the intensity. As the intensity increases, the current also increases. The fourth one, okay. The fourth one is the kinetic energy of the emitted electrons. Well, when does so the emitted electrons, can move faster. Whatever the energy supplied by the incident photons, the energy is more, part of it will be used up just to release the electrons from the surface of the metal. The remaining energy will be used up for the kinetic energy. That will come to it a little later. All right. So the kinetic energy of the emitted photoelectrons, is directly proportional to the frequency of the incident light. More the energy of the incident photons, the kinetic energy is also more. Lesser the energy of the incident photons, lesser will be the kinetic energy. Well, when you plot a graph of the kinetic energy versus frequency, where this variation, look at this. Only the kinetic energy starts from certain value. That is the threshold frequency, nu naught. This value is the threshold frequency. And this is, 1 second. Well, now, so this is the curve. So the when you extrapolate the curve, this is nu naught value and this is h nu naught. That is the work function that I will tell you so little later. Okay, and the slope of this, that gives h. How it is h, that also I'll tell you later. Okay, so right now kinetic energy of the emitted photoelectrons, so directly proportional to the frequency, just depends on the frequency of the incident light. The fifth one, in the normal course, the cathode will be made negative and the anode has been made the positive. Suppose if the reverses the polarity, so that the potential given to the cathode has been made positive and the anode has been made negative, then the emitted electrons, still reaches the anode and flows in the external circuit because they will have a lot of kinetic energy with which they can overcome the repulsion between the electrons and the negative potential given to the anode, and still current will be there in the external circuit. If we keep on increases the negative potential given to the anode for a particular negative potential, so the emitted electrons completely will be repelled by the negative potential given to the anode, thereby the emitted electrons, completely stop reaching the anode, and that negative potential given to the anode is called the stopping potential. The minimum negative potential given to the anode for which the emitted photoelectrons, completely stop reaching the anode is called the stopping potential. That is Vs. Okay. Well, of course, the kinetic energy of me square, that is equal to the charge into the potential applied, that is Vs of me square, that is equal to EVS. Anytime, can make use of this relation. Well, the next one, well, photoelectric, so the Einstein's photoelectric equation. Well, another few minutes, I will discuss after that, we shall, so switch to the questions. Well, Einstein's photoelectric equation. Whatever the light incident of the metal, that will be used up for two purposes. The energy of the incident light is E is equal to h nu. Well, whatever the light incident of the cathode, that will be used up for two purposes. One is just to remove the electrons from the surface of the metal, because these electrons are bound to the surface of the metal, as a result of which whatever the energy that has been supplied to the metal, so part of it will be used up just to remove the electrons from the surface of the metal, called the work function, denoted by W, that is equal to h nu naught, that is also equal to hc by lambda naught, where nu naught is called the threshold wavelength and lambda naught is called the threshold wavelength. Okay, and the remaining energy, the incident light, so incident light, that will be used up for the working energy of the kinetic energy of the emitted photoelectrons, Ke, that is equal to half mv square. So the energy of the incident light is equal to W plus kinetic energy, since the source of the work function as well as kinetic energy, well, is the energy of the incident light only. E is equal to W plus kinetic energy. This is called Einstein's photoelectric equation. This equation has fetched him the Nobel Prize also. This is a Nobel Prize equation. Well, E is equal to W plus kinetic energy. This is called Einstein's photoelectric equation, and this equation successfully explains all the experimental observations. Of course, the various versions of this equation, E is equal to h nu, that is equal to h nu naught plus half mv square. Well, this also can be written as Hc by lambda, that is equal to Hc by lambda naught plus half me square. Anytime, as I told you, this half me square, that can be equated to E into Vs. Well, incident light, the wavelength could be given, and the work function threshold frequency could be given, and in this, the kinetic energy, the stopping potential could be given. Charge multiplied by the stopping potential or the voltage, always that the kinetic energy of the emitted electrons. Okay. Well, so this is Einstein's photoelectric equation. This equation successfully explains all the electrical, so all the experimental observations of the photoelectric effect, whatever we have made. Okay, let me not just go into the details of how it has explained. All that is not really required. Okay, these are the various versions of the photoelectric. So the Einstein's photoelectric equation. All right. Well, the next one is the photoelectric cells. A photoelectric cell is a device which converts the light energy into electrical energy. Different types of photoelectric cells are photoemissive cell, photoconductive cell, and photovoltaic cell. Photoconductive cell, and the next one is photovoltaic cell. Okay, the photoemissive cell, as usual, like it consists of a cathode. This is the cathode in the form of a semi-cylindrical plate. Okay, and an anode. Anode is a metal, a metallic rod. Both of them, they have been enclosed in an evacuated glass tube. The cathode, as usual, that has been connected to negative of a battery. Anode has been connected to positive of the battery through a load resistor. Load resistor, that is across which output has been taken. That's all. When light and suitable frequency incident of the photocathode, photoelectric effect takes place, emitted electrons, reaches the anode and flows in the external circuit, so giving rise to current called the photoelectric current. The output current, has been taken across the load resistor. This is the photoemissive cell. Photoconductive cell. It consists of a and it works under the principle of the resistance of a semiconductor decreases with the increase in temperature. As the temperature increases, so the resistance, resistance decreases with the increase in temperature. All right. So how the photoconductive cell works, it consists of a semiconductor. This has been placed below a thin transparent film, and the combination has been placed over the stable iron plate. This is the semiconductor. Okay, now when light incident of the semiconductor, what happens? The photoelectric effect takes place. Well, that is the sorry, this when light incident of the semiconductor, when the temperature, so temperature increases, thereby the resistance decreases. Okay, well, and so now the emitted electrons, they are made to move in the in the external circuit by applying the potential. Okay, this is the positive potential, negative potential. This is the photoconductive cell. Next, photovoltaic cell. So photovoltaic cell is also so very simple. It consists of the copper plate on which a thin layer of cuprous oxide will be deposited by exposing the copper plate to the air. Okay, and to have the stability, another plate. So the another plate will be deposited. So another plate will be placed over the cuprous oxide layer. So, for example, the silver or gold, a thin layer of silver or gold has been deposited over the cuprous oxide layer. Here, so this so here the semiconductor is the cuprous oxide layer. Okay, when light incident on the cuprous oxide layer, photoelectric effect takes place, and so this is the cuprous oxide layer. That is the photometal. Okay, now the electrons are ejected. The ejected electrons, they move toward the silver film, and thereby the silver film becomes a negative potential, whereas this end, becomes positive potential. Thereby, a potential will be developed between the silver film and this copper plate. So this, whatever the potential developed, that is more than sufficient to drive the electrons which has been emitted in the cuprous oxide layer, and this is the load resistor across which output has been taken. So without the external potential, Well, current has been drawn in the circuit, therefore it is called the photovoltaic cell. Okay. Well, so this is about some of uh, the the ideas regarding the photoelectric effect. Well, with this, we can go ahead with the questions. Okay. Well, also we have a few questions in the beginning. We have a few more questions, and they were depends on the de Broglie waves or the matter waves. Well, what are de Broglie waves or matter waves? Certain phenomena in physics such as the interference, diffraction, polarization can be explained by treating the light exclusively in terms of waves. Other phenomena such as the photoelectric effect and the Compton effect. So all of you got what is photoelectric effect? Light incident on a metal, electrons are ejected. That phenomenon is called the photoelectric effect. What is Compton effect? When a photon has been scattered by an electron, this is the photon. When a photon has been scattered by an electron, when a photon incident on the electron, the photon gets scattered, and this is the wavelength of the scattered photon. This is the scattered photon. And the wavelength of the incident photon is lambda, and the scattered photon wavelength is lambda dash. This is the direction of the incident photon in the absence of the electron. Okay, and this is called the scattering angle. Lambda dash is greater than lambda. This is called Compton effect. Okay, so certain phenomena in physics such as the interference, diffraction, polarization can be explained by treating the light exclusively in terms of waves. Other phenomena such as the photoelectric effect and the Compton effect can be explained by treating the light exclusively in terms of particles. Therefore, light has got both the particle nature as well as the wave nature, because both are observed phenomena, and the photoelectric effect and the Compton effect can be explained only by treating the light in terms of particles, whereas interference, diffraction, polarization can be explained only by treating the light in terms of the waves. So therefore, light behaves both as the particle as well as the wave. This double nature of light was first explained by de Broglie. According to de Broglie, not only light is double in nature, the whole of matter, is double in nature. According to de Broglie, any particle moving with certain velocity can be treated as both as the particle as well as the wave. Well, the waves associated with the matter particles are called de Broglie waves or matter waves. Example, the motion of an electron around the nucleus in an orbit. The motion of an electron around the nucleus in an orbit, this is the classic example for the de Broglie waves or matter waves, because electron behaves both as the particle as well as the wave. And the running vehicles, they are also de Broglie waves or matter waves. The flight of birds, running train. ಏನಾಯ್ತು? Problem. Well, sorry for the interruption. Well, now please kindly not to share the screen, thereby it will be it's a disturbance. Please kindly make sure that so the sharing of screen won't be there. All right. So what are de Broglie waves or matter waves? According to de Broglie, any particle moving with certain velocity can be treated as both as the particle as well as the wave. The waves associated with the matter particles are called de Broglie waves or matter waves. Example, the motion of an electron around the nucleus in an orbit. The electron can be treated as both as the particle as well as the wave. So motion of the motion of vehicles, okay, running train, flight of birds, Earth going around the sun, all of them, they are the examples for the de Broglie waves or matter waves. But in case of heavier bodies, the wavelength is very small of the order of 10 to the power of minus 40 meter. Hence, wave nature has been ignored and only particle nature will be predominant. Okay, so we have to have an expression for the de Broglie wavelength that is as follows. According to Einstein's mass energy relation, E is equal to mc square. According to quantum theory of radiation, the same energy that is equal to hc by lambda. Okay. Well, so therefore lambda that is equal to h upon mc. This is the expression for de Broglie wavelength. But all particles will not move with a speed equal to the speed of light, where c is the velocity of light. In that case, de Broglie wavelength is lambda is equal to h by mv. And yeah, mass into the velocity, that is also the linear momentum. Okay. Well, if the kinetic energy of the particle is capital E, that is equal to half mv square, then V that is equal to 2E divided by m under the root. This value of V, substitute in this equation, this is the middle equation, then lambda becomes h upon m into 2E by m, okay, under the root. This m can be written as root m into root m. This is h upon 2m into capital E. Well, this is in terms of the kinetic energy, okay. And if the particle has been accelerated by applying external potential, then kinetic energy of me square I was using in the couple of minutes back E into V. Okay, so therefore this implies what is V, this is 2 EV divided by m under the root. This value of V, once again substitute in this equation, you get lambda that is equal to h upon m into, I am substituting this value of small v in this the same equation, m into 2 EV divided by m under the root. Thus can be written as root m into root m. Finally, h upon 2m into small e into capital V. This is in terms of potential. Okay. So these are the various versions of the de Broglie wavelength. Lambda is equal to h upon mc, lambda is equal to h upon mv, h upon p in terms of kinetic energy. Well, this is the one. H upon square root of 2m into small, so 2m into capital E. And in terms of the applied potential, is this. Well, suppose the m has been, so the particle remains same, okay, then lambda is inversely proportional to the velocity. And suppose if the kinetic, so the mass of the particle, so in terms of kinetic energy, lambda is inversely proportional to E. Suppose if different particles are there, then lambda is inversely proportional to m into root T. And in terms of the potential, lambda is inversely proportional to the potential. Okay. So now with this, we can start the questions. I think you can just copy it. You can take the screenshot. Well, so the first question, I think you can take the screenshot if you want. Otherwise, synopsis, the synopsis, it's been mentioned very clearly, all of them. Of course, I have given some extra information also. Well, the first question, the ratio of wavelength of photon and that of an electron of same energy. Okay. Well, so the photon, the rest mass of a photon is equal to 0, whereas the rest mass of the electron is not equal to 0 and E is equal to mc square. All right. The ratio of wavelength of a photon, lambda, that is equal to hc by E, or E is equal to hc by lambda. Wavelength of a photon, the ratio of wavelength of a photon and that of an electron. What is lambda of electron? That is equal to, well, this is h upon square root of 2m into capital E. This is the wavelength of the electron. Okay. Now this is the photon and this is the electron. Okay. So this h and h gets cancelled. Okay. Well, this is equal to, well, c into Well, this root up to m goes to the numerator, that divided by e. Well, this can be written as root m into, well, root e into root e. Well, one root and one root gets cancelled finally. Root up to m by e. I think you followed, no? Well, this e can be written as root e into root e. One root e gets cancelled because this 2m root up to m can be written as root up to m into root e. Okay. Well, that root e and root e gets cancelled. Another root e has been left. C into root up to m by e. Well, this is the answer. Well, you can't use the same so same equation like this because it has rest mass of the photon, that's equal to 0. Well, whereas it has the rest mass, therefore the wavelength of the electron is h upon square root of m into capital E. Well, the next question, the energy that should be added to an electron to reduce its de Broglie wavelength from 1 meter, 1 nanometer to 0.5 nanometer is the energy that should be added to an electron to reduce its de Broglie wavelength from 1 millimeter to 0.5 to nanometer. Well, so the energy, so the de Broglie wavelength, how it depends on the electron is telling. So de Broglie wavelength lambda, that is equal to h upon square root of 2m into capital E. Since it's the same particle, lambda is inversely, so he is adding, he is mentioning only for the electron, lambda is inversely proportional to root of E. Okay, well, so therefore what is lambda 2 by lambda 1? So that is E1 by E2 under the root. Okay, so therefore he is asking what is the energy to be added. Okay, so therefore this implies what is otherwise you can also say E2 by E1, squaring both the sides and taking the reciprocal, that is equal to lambda 1 square by lambda 2 square. Am I correct? Well, so this otherwise you can just omit this and you can straight away take this E2 by lambda 1 by, you want I can write it, lambda 1 by lambda 2. So that is equal to root E2 by E1. Okay, if we square this, lambda 1 square by lambda square, lambda 2 square, that is equal to E2 by E1. Okay, well, so therefore what is E2? E2 that is equal to, well, E1 into lambda 1 square by lambda 2 square. What is asking? How much energy has to be added in order to reduce the wavelength from 1 nanometer to 0.5 nanometer? Lambda 1 is 1 nanometer. 1 into 10 power minus 9. This is 0.5 into 10 power minus 9. So this is not really required to write the minus 9 because in both of them it's a common. So this is a 1 square by 0.5, the whole square. So that is equal to this 0.5 is 1 by 2. 1 by 2 whole square is 4. Of course, E1 is also there. 4, so 4 E1. In order to reduce the wavelength from 1 nanometer to 0.5 nanometer, energy, the new energy should be 4 times the initial energy. But what he is asking, how much energy has to be added in order to increase it, in order to reduce its wavelength from 1 nanometer to 0.5 nanometer. Already, so the electron has an energy of E1 initially. How much more energy has to be added to become 4E? That is 3 times its initial energy. The additional energy is 3 times the energy that should be added to an electron to reduce its de Broglie wavelength from 1 nanometer to 0.5 nanometer is so 3 times the initial energy. When you add, finally it becomes 4 times the energy, and so therefore the additional energy is 3 times the initial energy, because so the electron has the initial energy of E1. How much energy to be added in order to become 4E1, that is 3E1. So 4E1, 3 times the initial energy. Well, the next one. Should I give some time just to copy or something like that? Should I give some time for the copying? Or you can just take the screenshot? Question number 2. Okay. Fine. Say the energy that should be added to an electron to reduce its de Broglie wavelength. The energy that should be added to an electron to reduce its de Broglie wavelength from 1 nanometer to 0.5 nanometer. Well, the de Broglie wavelength, how it depends on the energy. Lambda is lambda is inversely proportional to the energy. What he is telling? Initially, it has one way, so 1 nanometer. To reduce 1 nanometer to this is this is the root of E. To reduce 1 nanometer to 0.5 nanometer, what is the energy? The energy to be added to the electron. Okay, let us say the initial energy of the electron is E1. Okay. And what should be the final energy, or what is the energy to be added in order to reduce the wavelength from 1 nanometer to 0.5 nanometer? All right. Now, what is lambda 1 by lambda 2? That is equal to root of, since it's inversely proportional, root of E2 by E1. Am I right? Squaring both the sides. Lambda 1 square by lambda 2 square, that is equal to E2 by E1. So therefore, what is E2? E2 that is equal to E1 cross multiplication, E1 into lambda 1 square by lambda 2 square. Correct? So lambda 1 is 1. So this is 0.5, 0. Nanometer, nano gets cancelled. Okay. So let me write it here. So this is E1 into 1 square by 0.5, that whole square. The conversion nanometer square, I just cancelled. 0.5 is same as 1 by 2. 1 by 2, that is 1 by 2 whole square, that's a 4E1. E2 must be equal to 4E1. The energy of the final energy of the electron should be equal to 4 times the initial energy. Already initial energy is E1. How much more has to be added? The energy that should be added to an electron to reduce its de Broglie wavelength. Already it has the energy of E1 in the beginning. How much more has to be added in order to become a 4E1? That is 3E1. So E2 that is equal to E1 plus 3E1. If I add 3 times the initial energy, then the final energy becomes the 4E1. Then the wavelength reduces to 0.5. I hope I have made it clear. Well, the next one. If Vm and Vr, so V0 are the maximum velocity of the photoelectrons and the stopping potential, then Vm square by V0 is equal to of mv square maximum, that is equal to E into V. The kinetic energy that is equal to the product of the, sorry, this is into. It's not minus, this is into, all right. Okay, of mv square that is equal to of mv square maximum, that is equal to E into V naught. Okay, well, so therefore what is Vm square by V naught is asking. That is equal to cross multiplication, that is 2 into E by M. And E by M, is this is called, this ratio is called the specific charge. So 2 times the specific charge is the value of so Vm square by V naught. Okay. Well, the next one, a graph of Vm and V naught is so what is Vm and V naught? Okay. Well, Vm square is directly proportional to V naught. Forget about the constant here. M is the mass, and 2, of course, 2, the charge is also constant. Okay. So Vm square is proportional to V naught. Vm is proportional to V naught, root of V naught. Okay. let us say V naught is equal to 25. Then Vm is equal to 5. And V naught is equal to, let us say next one is 16. Then Vm is equal to 4. Let me take the exact squares only. And so V naught is equal to, let us say that is 9. Then Vm is equal to 3. Okay, when you plot a graph of this, you get a straight line. You want, I just tell you this is a graph of Vm versus V naught. So Vm is, let us say this is 5, this is 10, this is 15, 20, and 25. And this is again 5, 10, 15, 20, 25. Look at this. When we are Vm is, so when V naught is 25, this is the value. And what is the, so Vm value that is equal to, how much is this? Well, that is 5. Vm is equal to 5. Onchೂರು ಇದಾಗ್ತೈತಲ್ಲ nice. Well, and when Vm is equal to 16, when V naught is equal to 60, this is the 20, 16, let us say somewhere here, okay? And what is Vm, that is equal to 4. So this is 4, slightly less. Very less than the 5. So like this, and when so V naught is equal to, so 9, so Vm is equal to 3. That is so Vm is equal to 3. This is 9 and this is 10 and this is some area. So this is almost this is a straight line only. Okay. So a graph of Vm and V naught, that's a straight line. Well, the next one. So all components of electromagnetic spectrum in a vacuum have so it's a electromagnetic spectrum. The light, that has been classified into various regions such as the gamma region, X-ray region, UV region, visible region, so IR region, the radio region, IR region, and the microwave region, and so on. Up the gamma, that is right. The frequency is 3 into 10 to the power of 20 to 3 into 10 to the power of 19. Maybe if you remember this, that will be convenient. And its wavelength is 0.1 to 0.1 Armstrong. Okay. X-rays, will have a frequency of 3 into 10 to the power of 19 to 3 into 10 to the power of 16. Well, this might be useful to you in answering some of the questions. 0.1 to 0. This is 100 Armstrong. Okay. Well, whereas the UV, 3 into 10 to the power of 16 to hertz to 3 into 10 to the power of 14. 4 into 10 to the power of 14 hertz. Okay. Whereas this 100 Armstrong to 100 Armstrong to 4000 Armstrong. Visible, so the frequency is, well, 4 into 10 to the power of 14, the visible. 4 into 10 to the power of 14 to 8 into 10 to the power of 14 hertz. Whereas this 4000 Armstrong to 8000 Armstrong, I hope all of you could remember this. Well, all right, radios, like that, I can keep giving. Well, so now what he is telling, all components of electromagnetic spectrum, depending on the frequency and the wavelength, the light has been classified into various regions such as X-ray, the gamma region, X-ray region, UV region, visible region, radio region, infrared region, microwave region. So gamma will have the maximum frequency, hence the energy will be maximum. Well, this is the shortest wavelength and this is the longest wavelength. The longest wavelength or the shortest frequency, that will have the minimum energy. But all of them, depending on the frequency, the wavelength, they have been classified into the various regions such as X-ray, gamma region, X-ray region, UV region, visible region, radio region, IR region, microwave region. All of them, they cross the same speed. So the velocity will be the same. Okay. Well, so though they have different frequency and the wavelength, so they will move the same speed or velocity. Next one, the de Broglie wavelength of a proton accelerated, so the charge has been given, accelerated to a speed of 1 kilovolt. The de Broglie wavelength in terms of the potential, 2m into small e into capital V. In terms of the potential, in terms of the kinetic energy, 2m into capital E. Okay, well, so just substitute the values and PD is equal to 1 volt, and so of course the everything has been given. 6 point, you just see 6.625 to 10 power minus 34. That's the Planck's constant 2 into this is 1.6 into 10 power minus 90. Sorry, this is the mass is 1.6 into 10 power minus 27. And the charge is 1.6 into 10 power minus 90, and the potential is 1 kilovolt, 1 into 10 power 3. Very simple. This is minus 25, minus 27, and so minus 90, that is minus 36, minus 46, minus 46, and two zeros. Well, minus 46 and the two zeros, minus 44, minus 44 out of the out of the root, you know, that is minus 24 minus 22. Okay, minus 22 minus 34 gets cancelled, and minus 12 in the numerator, 10 power minus 12. And of question is a 16 square, that is a 256, 256, 2.56 into 10 is 256, 250 double, you know, that's a 500, and the root of 500, you know, that is equal to how much? Root of 500, well, that is a one second. So that is 20 is 400, 25 is that's 625, but somewhere between 20 and the 25 it comes okay. So by root of 500, you know, that comes between 20 and the 25. Let us say 20 itself, 6.625 divided by around 20. Okay, into 10 power minus 12. Well, this is 1 0, and this is minus 30, and 2, that's a 3.3. 3.3 into 10 power minus 30. So that is the de Broglie wavelength. So that is 3.3 roughly. So the one which comes close to this, you know, that is minus 12, 0.9 into 10 power minus 12. Well, I think I do not know whether you followed these calculations or not. I can just tell you once again. So what the method I use for the calculations, you know, I just tell you. Well, so these are rough calculations. You don't need to go for the final calculations. Okay, let me just tell you. This is minus 57 and minus 19, you know, that is equal to minus 46. Minus 46 and 10 power plus 2, minus 44. Another 10 has been left here. Minus 44 root, you know, that is the minus 22. Minus 22, minus 34 gets cancelled. Minus 12 in the numerator. Okay, 1.6 square, that is a 16 square. So 16 square is 256. Is 1.6 into 1.6 is 2.56. Into 10 is 256. 250 double is 500. And so root of 500 is between 20 and 25. Absolutely no problem. Once again, here the 20, one of the, so 20 can be written as 2 into 10 power of 1. That goes to numerator minus 13. Well, that is 3.3 into 10 power minus 13. Well, this is same as 9 into 10 power minus 13. This order. So this is the answer. So we don't really require the final calculations to come to that particular order, you know, that for a second. This is the right answer. Well, the next one. If an electron and a proton have the same de Broglie wavelength, then the kinetic energy of the electron is both of them have the same de Broglie wavelength, then the kinetic energy of the electron is the electron and proton have the same de Broglie wavelength, then the kinetic energy of the electron is okay. Well, now electron and proton have the same de Broglie wavelength. Lambda is inversely proportional to, well, all right. Now, already we have done this. Or Okay. So electron and proton have the same de Broglie wavelength. So therefore, what is the kinetic energy of the electron? The proton and the electron. All right. Lambda proton, that is equal to 1 second, sir, please. Lambda proton, lambda of electron. What is the lambda for the proton? H upon square root of 3m into 2mp and EP. That is equal to H upon 2m EE electron. Well, so what happens, MP EP that is equal to, well, root of MP EP that is equal to root of ME. So E squaring both the sides, ME EE. What is telling that the kinetic energy the electron is, okay. So E that is equal to EP, okay, MP by ME. So this is more than sufficient. Okay, well, MP by ME, this is 1836 times the mass of the electron by the mass of the electron. So the mass of a proton is 1836 times the mass of the electron. If you want to learn in the next class, well, this is get cancelled. So therefore, finally, 1836 EP. Certainly, mass of the proton is greater than the mass of the electron because this is minus 27, this is minus 31. So this mass of the proton is greater than the mass of the electron. So therefore, the energy of the electron is greater than more than that of the proton. The third one is the answer. Okay, we stop it here. We continue the next class. Thank you. Meet in the next class. Thank you.
Good morning, students. Good morning, students. Hope you people can see the screen what I'm sharing. Okay. Yesterday, we were discussing about finding the area. Yesterday, we were discussing about finding the area bounded by the parabola and the straight lines. We can go for these shortcuts only when the first one, the parabola is symmetric about x-axis, but our line is parallel to y-axis. Fine. In that case, the area bounded by the parabola and the line is 8 by 3 into m root of an. Similarly, when our equation of the parabola is x square is equal to 4ay, where our parabola is symmetric about y-axis. In that case, when our line is parallel to x-axis, then we can go for the shortcut. That is, the area is 8 by 3 m into root of an. Fine. This you should remember. When our parabola is symmetrical about x-axis and the line is parallel to y-axis, go for the shortcut. But when it is symmetrical about x-axis, but the line is parallel to x-axis itself, in that case, don't go for the shortcut. Then, when equation of the parabola is y square is equal to 4ax and our line is y is equal to mx, that is the straight line passing through the origin, then the area bounded between these two is given by 8a square divided by 3m cube. And similarly, when equation of our parabola is x square is equal to 4ay and our equation of the line is given by x is equal to my, then the area bounded between these two is given by 8a square divided by 3m cube. And finally, let us take up two parabolas, that is y square is equal to 4ax and x square is equal to 4by. In this case, the area bounded between these two parabola is given by 16ab divided by 3. Okay, going for shortcut is good, but before that, you should know when we can go for the shortcut and when we should not go for it. Fine. Now, let's move on to the problem. The problem is, if the area between y is equal to mx square and x is equal to my square, where m is greater than 0, is 1 by 4 square units. Then the value of m is, options are plus or minus 3 root 2, plus or minus 2 root 3, root 2, and the last option is plus or minus 2 root 3, 2 divided by root 3. Okay, here already the area between the parabola y is equal to mx square and x is equal to my square is given for us, that is 1 by 4, and by using this value here it is asked to find out the value for m. And when we have two parabolas, already we know the result, that is area enclosed between the parabolas y square is equal to 4ax and x square is equal to 4by, is given by 16ab divided by 3. Fine. And here the equations what we have, are, it is my square is equal to x, or we can consider this as y square is equal to 1 by m into x. So in place of this 4a, here we have it as 1 by m. So a is nothing but 1 by 4m. Similarly, the equation what we have with respect to x square is, it is m into x square is equal to y, or x square is 1 by m into y. So in place of this 4b, here we have 1 by m. So b is nothing but 1 divided by 4m. Okay, then the area between the two parabolas is 16ab divided by 3, where a is 1 by 4m for us. B is also same, that's 1 by 4m, whole thing divided by 3. But here already we know the area bounded between these two parabolas, that is 1 by 4. So now let us do the simplification. So it is 1 by m square, whole thing divided by 3, or it is 1 divided by 3m square is equal to 1 by 4, or 4 divided by 3 is m square. From this, we can consider m as plus or minus root of 4 by 3, which is equal to plus or minus 2 by root 3. Fine. So the correct answer is option D. Now let's move on to the next. The area of the region bounded by the curve x square is equal to 4y and the straight line x is equal to 4y minus 2. The options are 3 by 8, 5 by 8, 7 by 8 and 9 by 8. Okay, here it is asked to find out the area bounded between. Here it is asked to find the area bounded by or bounded between the curves x square is equal to 4y and the line x is equal to 4y minus 2. And when it is x square is equal to 4y, our parabola is symmetric about y-axis. Let us consider the parabola on our xy plane. Fine. Then it is the line x is equal to 4y minus 2. And to consider this line on our xy plane, first to find out the point on x-axis, consider value of y as 0. So we are going to get x as minus 2. And to find out the point on y-axis, consider x as 0. Then value for y is 2 by 4 or it is 1 by 2. Fine. Therefore, the line here what we have, that is x is equal to 4y minus 2 is the straight line joining the points minus 2 comma 0 and 0 comma 1 by 2. So here the point is corresponds to this. The point on our x-axis is minus 2 comma 0 and corresponds to this. Here the point is 1 minute. So our straight line is the point joining the point. Straight line is joining the points -2, 0 and 0, 1/2. Okay, here along with this, here it is asked to find out the area bounded between the line and the parabola. This what the required area, what we have to find out. Okay, and to find out this, let us find out the point of intersection here what we have. And to find out the point of intersection, the equation of the parabola what we have is x square is equal to 4y, and equation of the line what we have is x is equal to 4y minus 2. And now substitute this 4y as x square, or consider this 4y as x plus 2 in the previous equation. Then we'll get our equation as x square is equal to x plus 2, or our equation is x square minus x minus 2 is equal to 0. So based on this, we can consider the equation as x square minus 2x plus x is equal to 0. So the factors are x minus 2 and x plus 1. So from this, values of x are 2 or 1. Therefore, the point here on x-axis is -1. So the point here on our x-axis is -1, 0, and here it is 2, 0. And to find out this area, first let us find out the area from x-axis to the line. In that, next we'll subtract the area bounded by x-axis to the parabola. Fine. So the required area is the area from x-axis to the line, and from this equation of line, our y is nothing but x plus 2 divided by 4. So it is x plus 2 by 4, and we have to integrate from -1 to 2. And in this area, we have to subtract the area bounded by x-axis to the parabola. So it is again integration of equation of our parabola is y square is equal to 4y, or from this y is x square by 4 into dx, and we have to integrate this from -1 to 2. 1 by 4 is constant. Let us consider that outside the integration. Now integration of x, that's x square by 2, integration of 2, that is 2x, between the limits -1 and 2. Minus, again here consider 1 by 4 as constant outside. Integration of x square is x cube divided by 3, between the limits -1 and 2. And now from these two terms we can consider 1 by 4 as common. Now let us substitute the upper limit and the lower limit. Always it is upper limit minus the lower limit. For upper limit 2, our x square is 2 square, that is 4, minus the lower limit. And for lower limit -1, it's -1 the whole square, that's nothing but +1. And the next term is 2x Upper limit is 2 minus the lower limit is minus 1, so minus of minus, that is plus 1. Next, 1 by 4. 1 by 4 already we have taken as common from both the terms. So here it is 1 by 3 constant. Then for upper limit it is 2 cube or 8 minus the lower limit minus 1 the whole cube, that is nothing but minus 1. So it is 1. And now 8 plus 1, 9, 3, simplify this. So it is 1 by 4 times, here it is 3 by 2 plus 6 minus 3. So plus 6 minus 3, that is 3. So it is 1 by 4, 3 by 2 plus 3, or it is 1 by 4 times of 9 by 2, or it is 9 by 8. So our answer is option D, 9 by 8. Fine. Here the curve, they have given the curve as x square is equal to 4y. They have not mentioned it as the parabola. Identifying it as the parabola and whether it is symmetrical about x-axis or y-axis, that is very important. Let's move on to the next problem. The area of the region above the x-axis included between the parabola y square is equal to x and the circle x square plus y square is equal to 2x in square units is, it was the problem what is asked in 2019 paper. Options are 2 by 3 minus pi by 4. Second option is pi by 4 minus 3 by 2. Next one, pi by 4 minus 2 by 3. And the last option is pi by 2 minus, so 3 by 2 minus pi by 4. Okay, here it is asked to find out the area above the x-axis between the parabola y square is equal to x and the circle x square plus y square is equal to 2x. So here to find out this area, let us use the result what we have. The area of the region above the x-axis included between the parabola y square is equal to ax and the circle x square plus y square is equal to 2ax is pi by 4 minus 2 by 3 into a square. But here the equation of the parabola what we have is y square is equal to x. That means a value is 1. And equation of the circle what here we have in our problem is x square plus y square is equal to 2x. So again value for a is 1. And when a is equal to 1, by using this result, the required area is pi by 4 minus 2 by 3 whole thing into a square. But here value for a is 1, so it is 1 square. So our final answer is pi by 4 minus 2 by 3. That is our option C. Fine. Now let's move on to the next. Take down the problem as the area of the region in the first quadrant bounded by y is equal to 2x minus x square and the x-axis. Options are 8 by 3, 4 by 3, 7 by 3 and 2 by 3. So here the curve what is given for us is y is equal to 2x minus x square. This we can consider as x square minus 2x is equal to minus y, or by adding and subtracting 1, x square minus 2x plus 1 minus 1. Just add and subtract by 1. Then this x square minus 2x plus 1 is nothing but x minus 1 the whole square. And when we consider this minus 1 to LHS, it's minus y plus 1. Or we can write this equation as x square minus x minus 1 the whole square is equal to minus of y minus 1. But the general equation of the parabola, what we have is x minus h the whole square is equal to minus 4a into y minus k. So now you can see in place of h it is 1 and in place of k it is 1. So vertex of the parabola is at 1 comma 1. And since we have this negative sign, shape of the parabola is in this form. Fine. And here it is asked to find out the area bounded by x-axis and the parabola in the first quadrant. So this what the area we have to find finally. And to find out this, first let us find out the points here what we have on our x-axis. Generally, when it is the point on x-axis, y value is equal to 0. And here the point easily we can make up, that is 0 comma 0, that is the origin. And to find out the point here in equation of our parabola, consider this y value as 0. And when y value is 0, 2x minus x square is equal to 0, or two minus x is 0, or from this x is equal to 2. So the point here what we have is 2 comma 0. And to find out this area, let us consider the rectangular strip from x-axis to the parabola. And our required area is integration of f of x. That is here, our equation of the parabola is y is equal to 2x minus x square. And we have to integrate this between x is equal to 0 and 2. So that is integration of x, x square by 2, integration of x square, x cube by 3 between the limits 0 and 2. Now, let us consider the limits. For upper limit, our x square is 4, that is 2 square, and for the lower limit, it is 0. And similarly, the next 1 by 3 constant as it is. For upper limit, it is 2 cube, and for the lower limit, it is 0. Fine. So it is 4 minus 8 by 3. And that is nothing but 12 minus 8 by 3, or it is 4 divided by 3. So the answer is option B. Good. Murli gave the answer. Very good. Thank you, Murli. Now let's move on to the next. So here, one thing what I want you people to be a bit careful is when it is the equation of the parabola as x square is, when we have equation of the parabola as x square is equal to 4ay or y square is equal to 4ax. In that case, when the line is just the straight line passing through the origin, then we have shortcut to find out the area. But when it is not the line which is passing through the origin, or if we have line like this, that is x-axis, in that case, we can find out this area only by integrating the equation. Fine. Now let's move on to the next problem. Area bounded by the curve y is equal to x cube and the x-axis, and also the ordinates x is equal to minus 2 and x is equal to 1. And the options given for us are minus 9, minus 15 by 4 plus 15 by 4 and 17 by 4. So here it is asked to find out the area bounded by the curve y is equal to x cube, x-axis, and the ordinates x is equal to minus 2 and x is equal to 1. So first let us consider this curve y is equal to x cube on our xy plane. Then x-axis already we know, that is when we have that already we have in our xy plane. Then the ordinates x is equal to minus 2 and x is equal to 1. So here what is asked to find is the area bounded by the curve y is equal to x cube, the ordinate x is equal to minus 2 and x-axis, and also the area bounded by the curve y is equal to x cube, the ordinate x is 1 and x-axis. So let us consider this as area A1 and A2. So for us, now the required area is sum of these two, that is A1 plus A2. Now let us find out A1 and A2. Our A1 is integration of y into dx, where here y is x cube. So it is integration of x cube between the points. Here it is minus 2 comma 0 and 0 comma 0. So integration is between minus 2 to 0. Then integration of x cube is x power 4 by 4 between the limits minus 2 to 0. 1 by 4 is constant. Let us consider that as it is. For upper limit 0, our x power 4 is 0. And for lower limit minus 2, it's minus 2 to the power of 4. Or it's 1 by 4 minus 2 to the power of 4 is nothing but 2 power 4, and that we can simplify as finally 2 square, or it is 4. And generally when it is the area, we neglect this minus sign. So finally consider this A1 as 4. Similarly, let us find out this A2. A2 is nothing but the area bounded by y is equal to x cube, the ordinate x is equal to 1 and x-axis. So our A2 is integration of x cube between x is equal to 0, and here the point what we have is 1 comma 0. So integration is between 0 and 1. Again, integration of x cube is x power 4 by 4 between the limits 0 and 1, which is equal to 1 by 4. Now let us substitute these two in our required area. Our A1 is 4 and we got A2 as 1 by 4. So our final answer is, it is 16 plus 1, that is 17 by 4. That's what the required area is. So the correct option is answer D. Very good, Murali. For this also I got answer from your side. Now let's move on to the next. Area bounded by curve is same here, that is y is equal to x cube, but our area is bounded by the curve x cube and the line y is equal to 8 and x is equal to 0. And this question was asked in 2015 paper. Options are 2, 14, 12 and 6. So to find out the area, first let us consider the curve y is equal to x cube. Then it is the line y is equal to 8. When it is y is equal to 8, it is the straight line parallel to our x-axis. And our x is 0. X is 0 is nothing but our y-axis. So here we have to find out the area bounded by these three curves. Okay, here instead of considering it as f of x into dx. Let us consider the horizontal strip in this required area. So it is integration of f of y into dy, where y varies from, here it is the origin, that is 0, 0, and here it is the line y is equal to 8, so it is 0, 8. So our y varies from 0 to 8. Fine. And here y is equal to x cube. From this, we can consider x as y power 1 by 3. So our f of y is y to the power of 1 by 3. So it is integration of y power 1 by 3 into dy between the limits 0 to 8. And integration of y power 1 by 3 is y power 1 by 3 plus 1 divided by 1 by 3 plus 1, or directly you can write that as y to the power of 4 by 3 divided by 4 by 3, or it is 3 by 4 into y power 4 by 3 between the limits 0 and 8, and that is 3 by 4. For upper limit 8, it is 8 power 4 by 3 minus, for lower limit 0, it is 0. So 8 power 1 by 3 is nothing but 2, 2 to the power of 4 into 3 by 4, or it is 2 square into 3, or it is 4 into 3. So the answer is 12. So the correct option is C. Option C, that is 12. Why today I'm not getting answers very fast as our previous class? Few problems in our integration, definitely we can go for the shortcuts, but we can't consider the shortcut for all the problems. So few problems we have to work out by our regular integrations only. That maybe take some time. Now let's move on to the next. Okay, area of the region bounded by the curve y is equal to cos x between x is equal to 0 and x is equal to pi. The options are 2, 4, 3, and 1. This question asked in 2018 and also in 2017 paper. Okay, at least for this, I am expecting answer from your side within a minute. Okay. Here, what asked to find out is the area of the region bounded by the curve y is equal to cos x between x is equal to 0 and x is equal to pi. So here is our x is 0 and here it is pi. So we have to find the area below the curve, that is area bounded by the curve cos x from 0 to pi. Here, if you observe properly, the area what we have from 0 to pi by 2 is same as the area what we have from pi by 2 to pi. So our required area is, we can consider it as 2 times the area bounded by 0 to pi by 2. And our y is cos x into dx. Very good, Saujanya. Your answer is correct. It's 2 times integration of cos is sine between the limits 0 to pi by 2, and that is 2 times, when upper limit x, for the upper limit pi by 2 it's sine pi by 2, and for lower limit 0 our sine x is sine 0, and we know that sine 0 is equal to 0 and value for sine pi by 2 is 1. So the required area is 2. And without doing integration also, this you can remember. That is, the area bounded by the curve y is equal to cos x from 0 to pi is always equal to 2. And it is same for our sin x also. So instead of 0 to pi, if it is asked to find out for 0 to pi by 2, then it is nothing but half of this total area. So 2 divided by 2, which is equal to 1. So when it is a problem related to this sine or cos x curve, in that case, check these limits first. Okay, whether it is 0 to pi or 0 to pi by 2, check that once before writing your answers. Fine. Now let's move on to the next. The area bounded by one arc of y is equal to sine 4x and x-axis. Okay, as I told in the previous problem, here one area of that one complete arc from that is from 0 to pi. When it is sine x, it is 2. When it is given as sine ax, it should be a by 2. Okay, it's not only for sine, even for cos also. When it is asked to find out the area of the region bounded by one arc of the curve, and that may be sine or cos, sine ax or cos ax, the area is 2 divided by a. And here, the curve what we have is, in place of this sine ax, we have it as sine 4x. Therefore, value for a is 4. And when a is 4, the required area is given by 2 by a. When a is 4, it is 1 by 2. So the answer is 1 by 2, that is option A. Very good, Sarjanya. Okay, this you try to remember. The area of one complete arc of sine or cos curve is, it is 1 by 2. It is 2, and when it is sine ax or cos ax, it will be 2 by a. Fine. Now let's move on to the next. The area of the region bounded by the curve y is equal to sine x between the ordinates x is equal to 0 and x is equal to pi by 2, and also x-axis. The options are 2, 4, 3 and 1. You people give me the answer for this. Just now we have discussed for 0 to 4 pi, that is sine 4 pi, that is sine 4x. For this one, what is the answer? Here we have to find out the area bounded by the curve y sine x, where x varies from 0 to pi by 2. Very good, Shreya. Your answer is correct. 0 to pi by 2. We know that this complete area, that is area of one arc of our sine x is 2. But here it is asked to find out from x is equal to 0 to pi by 2. And when it is 0 to pi by 2, it is exactly half of the total area, which is equal to 2 actually. Total area is 2. When we consider half of that, it is nothing but 1. So the correct option is D. Our answer is 1. Good, Karthik? Fine. Keep this in your mind. Below the sin x or cos x, one area of one complete arc is nothing but 2. And when it is asked to find out between 0 to pi by 2 or pi by 2 to pi, in that case, it is half of that. So it's equal to 1. Fine. Now let's move on to the next. The area bounded by the curve y is equal to sine of x by 3, x-axis, and line x is equal to 0 and x is equal to 3 pi is 9, 0, 6, 3. That are the options given for us. Okay, you people give me the answer now. Nikita, your answer is correct. Good. Sine of x by 3. Okay, we know that the area between the one arc, the complete one arc below this sine AX it is 2 by A. And here it is asked to find out between x is equal to 0 and x is equal to 3 pi. X is equal to 0, and when x is 3 pi, here we are going to get it as sine pi, and value for sine pi is 0. So when x varies from 0 to 3 pi, it is nothing but one complete area of one complete arc below this sine x. Find the curve sine x. So here in place of A, it is 1 by 3. Therefore, the required area is 2 by 1 by 3, which is equal to 6. So the correct option is C. Some of you have given the answer as 0, but that's not correct. Okay, area below the sin x or one complete arc is nothing but always equal to 2 by A. And here in place of A, we have it as 1 by 3. So after the simplification, it is 6. Now let's move on to the next. Area bounded by y-axis, y is equal to cos x, y is equal to sin x, when x varies from 0 to pi by 4. And the options are 2 times root 2 minus 1. Second option, root 2 minus 1. Third option, root 2 plus 1. And the last option, root 2. Okay, here they have asked us to find out the area bounded by y cos x. This is what our cos x curve is, and y sin x. And when it is sin x, it passes through the origin. This is what our curve y sin x is, and y axis, where our x varies from 0 to pi by 4. Now, first let us find out what does this point of intersection is. Okay, that is the point of intersection of y is equal to cos x and y is equal to sin x. Y is equal to cos x and y is equal to sin x. So here, when we substitute y as sin x in the previous equation, we are going to get our equation as sin x is equal to cos x, or sin x by cos x is equal to 1. Or it is tan x is equal to 1, or x is tan inverse of 1, that is pi by 4. So here our value of x is pi by 4. Fine. And here it is asked to find out the area bounded by x is equal to 0 to pi by 4. So this is what the required area is. And to find out this area, first we'll find out the area from x-axis to our curve cos x. In that, we'll subtract the area from x-axis to sin x. So our required area is, it is integration of cos x, and that is from 0 to pi by 4. And in this area, we subtract the area from x-axis to the curve sin x, that is integration of sin x between 0 to pi by 4. That gives us the required area bounded by y-axis, y is equal to cos x and y is equal to sin x, where x varies from 0 to pi by 4. Fine. Integration of cos s sin, the limits given as 0 to pi by 4, minus integration of sin x is minus cos x, the limits 0 to pi by 4. So now for upper limit, our sin x is sine of pi by 4, and for lower limit it is 0. minus of minus becomes plus. For upper limit, our cos x is cos pi by 4, and for the lower limit, it is cos 0. We know sine 0 is 0 and cos 0 is 1. Value for this sine pi by 4 and cos pi by 4 is 1 by root 2. So finally it is 1 by root 2 plus 1 by root 2 minus 1, or that can be considered as 2 by root 2 minus 1, or it is root 2 minus 1. So the answer is option B, root 2 minus 1. Karthik, be careful when you are doing the simplification. It's not root 2 plus 1. Check once, it is root 2 minus 1. Now let's move on to the next. Area bounded by x-axis and the curve y is equal to log x, and also the line x is equal to 2. So in this case, our required area is bounded by the x-axis and the curve log x, and also the line x is equal to 2. The options are log 2, 2, 3 by 2, and 2 log 2 minus 1. Now, first let us consider the curve log x on our xy plane. We know that log 1 is equal to 0. So at the point 1 comma 0, our curve passes through the x-axis. And here it is the line, our area is bounded by x-axis, the curve log x, and the line x is equal to 2. So this what the required area is. Very good, Saujanya. Correct answer. Okay, this is what the required area is. So our required area is given by integration of f of x into dx. Here our f of x, that is y, is the curve log x. So it is integration of log x between x is equal to 1 to 2, because here the point is 2 comma 0. And whenever it is log x, integration of log x, we consider that as 1 into log x. And we use our integration by parts here by considering log x as first function and 1 as the second function. And the integration by parts, the rule of integration by parts is integration of u into v is, where u is the first function, v is the second function, first function as it is, integration of the second minus integration of the second and differentiation of the first. Here, let us consider log x as first function and 1 as second function. So according to our integration by parts, first function as it is, log x as it is integration of the second, and integration of 1 is x minus integration of the second function, that is integration of 1, which is equal to x, and differentiation of the first function, and differentiation of our log x is 1 by x. And here we can cancel x and x. So finally it is integration of x. So integration of our log x is x log x minus x. And here the limits are 1 to 2. Now let us substitute these limits. For upper limit 2, it is 2 log 2 minus 2. And for the lower limit 1, it is 1 into log 1, where log 1 is 0 and minus x becomes minus 1. So finally it is 2 log 2 minus 2, minus of minus 1, that is plus 1, minus 2 plus 1, that's equal to minus 1. So the required area is 2 log 2 minus 1. And that is our option D. So the correct option is D. Very good, Saujanya. Now let's move on to the next. Area lying in the first quadrant bounded by the curve y is equal to x plus 1 and the lines x is equal to 2 and x is equal to 3. Options are 7 by 2, 9 by 2, 11 by 2 and 13 by 2. So here our area is bounded by the curve, which is a straight line, y is equal to x plus 1, and the lines x is equal to 2, x is equal to 3 in the first quadrant. So now first let us consider this straight line y is equal to x plus 1. And to find out the straight line on our xy plane, to find out the point on y-axis, consider x value as 0. Therefore, our point on y-axis is 0, 1. To find out the point on x-axis, consider y as 0. So we are going to get the value of x as minus 1. So the point on our x-axis is minus 1, 0. And this equation y is equal to x plus 1, the straight line joining the points minus 1, 0 and 0, 1. Fine. Here, our region is bounded by y is equal to x plus 1 and the lines x is equal to 2, which is parallel to y-axis, and x is equal to 3, that is also parallel to y-axis. So the required area is bounded by the line y is equal to x plus 1 and these two lines x is equal to 2, x is equal to 3 in the first quadrant. And to find out this area, let us consider a vertical strip in the required region. So it is from x-axis to the line y is equal to x plus 1. So our f of x is nothing but x plus 1 integration of this between the values x is equal to 2 to 3. Consider that as limits. And integration of our x is x square by 2. Integration of 1 is x between the limits 2 to 3. So let us consider the limits now. For upper limit 3, our x square is 3 square, that is 9. And for lower limit 2, it is 2 square, which is equal to 4. And now for our term x, it is 3 minus 2, upper limit minus the lower limit. So it is 5 by 2 plus 1, or it is 7 by 2. So the required area is 7 by 2. So the correct option is A. Very good, Shravani. The next one is the area of the region bounded by the curve x is equal to 2y plus 3 and the lines y is equal to 1 and y is equal to minus 1. The options are 4, 9, 3 by 2, 6 and 8. We have just 2 minutes time. Okay, let me give the idea of what we have to find, the area what we have to find, then you people can continue. Okay. Here, the line what is given for us is y is equal to 2y plus 3. To find out this line on our xy plane, first let us find out the point on our x-axis and y-axis. To find out the point on x-axis, consider y as 0. So we are going to get value of x as 3. And to find the point on our y-axis, consider x value as 0, then we are going to get y as minus 3 divided by 2. corresponds to this. The point on our x-axis is 0, y-axis is 0, minus 3 by 2. So this what our line x is equal to 2y plus 3. And here our area is bounded by the line x is equal to 2y plus 3 and y is equal to 1, which is the straight line parallel to x-axis, and y is equal to minus 1, that is the straight line parallel to x-axis, but y value is minus 1. Fine. So here the required area is bounded by the line y is equal to 1, y is equal to minus 1, and x is equal to 2y plus 3. So instead of considering the vertical strip, better since we have y-axis in our region, consider the horizontal strip in this case. And whenever it is the horizontal strip, it is integration of f of y into dy. So our required area is integration of f of y into dy, where here y varies from minus 1 to 1. And our f of y from this equation is our y is x minus 3 by, so our x is 2y plus 3. So it's x into dy or f of y into dy. So it's integration of 2y plus 3 between the limits minus 1 and plus 1. This integration part you people can handle. Okay. So integration is actually not difficult. We have many shortcuts in our finding the area of the integral. If you people are able to remember that, it is really good. But you should know when we can go for shortcut and when we should not go for shortcut. If you know that properly, then scoring marks in our application of integral is really very easy. Fine. All the best students. Do well in your CET exam. Always hard work, give the success. If you work hard, definitely you can succeed in life. All the best. Do well. Thank you all.
Good morning, students. Today, let us discuss some few sample questions. Okay, based on for chemical bonding and molecular structure as well as redox reactions. Okay. Let us consider the first question. Bond angle in pH 4 is more than that of the pH 3. Okay, so what is the reason for this? So there are four options are given. pH 3 has a planar trigonal structure. Hybridization of the P changes when pH 3 is converted into the pH 4. Lone pair bond pair repulsion exists in pH 3, and the last option is pH 4 has a square planar structure. Okay, so let us see, so which is a correct answer. So here the pH 3 has a lone pair on central phosphorus atom, which is absent in pH 4 plus. Thus in pH 3 there will be a bond pair lone pair repulsion, and this is the reason why the bond angle in pH 3 is less than pH 4. To avoid the repulsion, the bonds are little bit bent, and hence the bond angle is get reduced in case of pH 3. So thereby, so what is the correct answer? The correct answer is going to be lone pair bond pair repulsion exists in pH 3. Okay. So this is the correct answer. Okay, so if you want, I will repeat. Okay, so if there is a the lone pair bond pair repulsion, to minimize that repulsion, so the bonds will be trying to lie as away from each other, and thereby because of this the bond angle will be get decreased in case of pH 3. Next question. So incorrectly matched, the pair is, the first pair is XeF6, which is having a distorted octahedral, XeOF4 square pyramidal, XeO3 pyramidal structure, XeF6 tetrahedral. Okay, and the solution is, in XeF6 there are 6 bond pairs and 1 lone pair. Thus the shape of XeF6 is distorted octahedral. That means the first option is correct, but we have to look for the incorrectly matched pair. So the first option is a correct one. The pair is correct. So our XeF6 is having distorted octahedral only. And in the second case, let us see XeOF F4. In that Xe is sp3d hybridized and the shape is square pyramidal. So this is also a correct option. So and the third one, XeO3, in that Xe is sp3 hybridized and the shape is trigonal pyramidal. So the third one is also correct. Then the answer will be none other than that of D, where XeF6, so it is given it as a tetrahedral, but the actual structure of this is square planar. The actual structure of XeF4 is square planar because it is having sp3d2 hybridized. It has 4 bond pairs and 2 lone pairs, and thereby so it is having square planar structure, but here it is given as a tetrahedral, thereby the wrong the pair incorrect pair is found to be the last one. So the answer is the last one, that is D. So the oxidation number of nitrogen atoms in NH4NO3 ammonium nitrate are, I'll repeat, the oxidation number of nitrogen atoms in NH4NO3 ammonium nitrate are. So you have to look for so in two the places you are finding the nitrogen. So in ammonia this part, and also in the second part, and also in the second part. Now we have to find the oxidation number of nitrogen in the part of that ammonium, that is NH4 as well as NO3. So let us see the solution. Now, so in this ammonium nitrate, so you should remember that NH4 will be present in the form of NH4 plus, and the anionic part is going to be, okay, NO3 minus. So this is present in the formula like cationic part is NH4 plus and the anionic part is found to be NO3, okay, the minus, NO3 minus, this is the one, okay. In NH4 plus, okay, how to calculate the oxidation number of, what is this, N, that is N. So whenever you are calculating the oxidation number of, okay, the polyatomic ion, then so the whatever the charge you are going to find over this, okay, that is the resultant of the oxidation number of nitrogen as well as the oxidation number of the hydrogen atoms which are present here. Okay, that's why. So whatever the charge we are finding here upon this Na, okay, NH4 plus, that is the resultant charge of these, okay, the corresponding atoms. Thereby, how to calculate the oxidation number of nitrogen? So for that, what you're supposed to do is, okay, see, we know the overall charge and we will be knowing this charge of our, okay, the H hydrogen, it is always, okay, the +1, okay, +1, thereby. So when you know the overall charge and the charge, okay, the oxidation number of this, okay, hydrogen, then so you just take the oxidation number of, okay, nitrogen in NH4 plus as a X and plus 4. Why it is 4? Because there are 4 hydrogen atoms and each, so ions, okay, and each will be having +1 oxidation state. Thereby 4 into 1, it is 4. Okay, that is equal to, and the overall charge which is present over this is found to be 1. And if you do this calculation, then you are going to get the X value as is equal to -3. Thereby oxidation number of nitrogen and this, okay, is found to be -3. Okay, please remember. So this can be replaced by any kind of molecules. Thereby you should be able to point out which is a anode, okay, cationic part and which is the anionic part, and then you very easily you can calculate the oxidation number for any of the atoms present in that particular molecule. So next, let us consider, so in the anionic part. So anionic part in this molecule is, okay, NO3 minus, NO3 minus. Okay, in this, what is the overall charge present over this? -1, -1. Okay, now we have to calculate the oxidation number of nitrogen in this particular molecule. Again, so as we know, okay, the oxidation number of oxygen is always -2. Okay, always it is -2. And how many oxygen, okay, atoms are here? There are 3. -2 into 3, it is nothing but -6. Okay, -6 here. Okay, and okay, the oxidation number of nitrogen here, it is taken as y. Y -6 is equal to the resultant charge we are finding here is as a -1. So thereby it is equal to -1. Thereby if you calculate y, you are getting it as +5. Then the answer is, okay, the first option, it is wrong, okay, because it is given as a +3 and -5, okay. And the second option, again it is wrong, okay. The third option, okay, no, it is wrong. And the fourth option, it is correct, okay, according to what we have calculated, okay, the oxidation state, so oxidation number of, okay, the nitrogens in the given molecule is found to be -3 and +5. Okay, this is the answer. Next question. Which of the following possess net dipole moment? Okay. See, remember students, in order to decide, okay, the answer for this question, okay, you have to record like the structures of, okay, major the molecules which are there in your syllabus. Okay, so you just record all the structures of the molecules which are there in your syllabus. Then if at all, if you are going to, okay, recall all the structures without looking into the whatever the solution I'm showing now, you can decide which is the correct answer. Okay, the what's the question? Which of the following, okay, possess net dipole moment, where that is new is having some value. Okay, new, that is the dipole moment. What is dipole moment? That is the product of Okay, so the here, okay, you must where nu is not is equal to 0, and then so what are the options which are given? BF3 is given, SO2, CO2, BeCl2. Okay, so let us see the solution. By seeing geometry, we can easily find out the net dipole moment. Okay, barium BeCl2 and CO2 have linear geometry. Okay, you just recall and imagine like what are the structures of these many molecules. Or BeCl2 is having a linear structure, and our carbon dioxide is also having a linear structure. Okay, linear geometry, and BF3 is having okay trigonal planar geometry with 0. Okay, thereby so in all these cases, okay, the dipole moment will be in the opposite direction. They will be get cancelled, and thereby the resultant mu is going to be 0 in case of BeCl2, in case of carbon dioxide, as well as in case of what is this? Okay, BF3, which is having a trigonal planar. Okay, trigonal planar. While SO2, okay, while SO2 molecule, it is having a bent shape due to the presence of lone pairs of electrons, okay, over the sulfur. Okay, just because of the presence of lone pairs of electrons, okay, our sulfur dioxide is having bent shape, okay, is having bent shape. Thereby, okay, which of the following is possess net dipole moment? You can say that, okay, our sulfur dioxide is having some, okay, dipole moment value. Okay, so the answer is B. Okay, now you just consider the formal charge on the central, okay, oxygen atom in ozone is. What is the formal charge? Okay, they are not asking the overall charge present on the ozone molecule. They are asking about what is the charge, okay, the formal charge which you can expect on the, okay, the central atom present in the ozone molecule. It is given us the options, okay, given are plus 2, plus 1, minus 1, and 0. Okay, let us see the, okay, the solution part. Now, so this is a ozone, and this is the resonance structure of this ozone. And here, okay, the central atom, I have named this as a, okay, the oxygen number 1. Okay, that is a 1. So central atom, I have taken it as 1. Okay, then in order to calculate formal charge, there is a formula. The formal charge present on any of the atom in a polyatomic ion or a molecule, okay, it is given by total number of valence electrons in free atom minus total number of non-bonding or lone pair of electrons present minus, okay, 1/2 of the total number of bonding or shared electrons. Okay, now you just, okay, concentrate on the central oxygen atom of the ozone, and now, okay, let us find out, okay, how many valence electrons are there. It is fixed because in oxygen there are 6 valence electrons. Okay, there are 6 electrons are present in the outermost shell. Thereby, so it is fixed, there's no change in that. Okay, so now total number of non-bonding, okay, or lone pair of electrons. Here you can see here there are 2, okay, electron, that is one lone pair of electron it is present, which is not involved in the bond formation. Okay, thereby there are 2, okay, lone pair electrons. And next, total number of bonding or shared electrons. So how many electrons are involved in bond formation? One bond is there, and here is a 2. Totally 3 bonds. In order to form 3 bonds, okay, 6 electrons are involved. Thereby, so total number of electrons involved in bond formation are found to be 6. So if you do this calculation, you are going to get the answer as, okay, plus 1. You are going to get the answer as plus 1. Thereby the answer is, okay, so even though it is displayed, okay, the first itself, just because of some mistake during animation, okay, so even though you got it, okay, know this as a B is the answer, but okay, logic behind this answer you must know. Thereby you can very confidently you can mark, okay, the answer is, okay, the plus 1. Now question number 9. the increasing order of bond order, the increasing order of bond order in case of O2, okay, this is O2 plus, O2 minus, it has to go to the, okay, subscript, there's some, okay, the mistake in that, and O2 2 minus, O2 2 minus, okay. So this is the order it is given, O2, O2 plus, O2 minus, and O2 2 minus, okay. So what they asked, the increasing order of bond order, the increasing order of bond order, where the number of, okay, the covalent bonds are present in between, okay, the two oxygen atoms, whether in case of what is this oxygen, or in case of O2 minus or O2 plus, okay, or O2 2 minus, okay. The different options are given here like A, B, okay. Now let us see, okay, the answer. So how to know the bond order? So bond order formula is given by bond order is equal to 1 half into the, okay, half of the number of electron in bonding molecular orbital, okay, number of electrons in the bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. Okay, so whatever number of electrons present in bonding molecular orbital, and this is the anti-bonding molecular orbital. Okay, so now, so once you know this, okay, so what is the total number of, okay, the electrons which we can find in case of oxygen, okay, the molecule. So there, so in the valence shell, okay, we can find, okay, the total is 16, okay, the 16 electrons are get involved in the bond formation, okay, that is in a, we can find in the molecule of oxygen, okay. So thereby bond order of oxygen, so if you calculate 1 half of the, so there are 10 electrons present in the bonding molecular orbital and 6 electrons are present in antibonding molecular orbital. There are 6 electrons, okay, present in the antibonding molecular orbital. Thereby, if you calculate, you are going to get the bond order as, okay, what is this? 2. Bond order as 2. Okay, now, okay, how to calculate bond order for O2 minus? So what is O2 minus? Okay, so from this O2, if you remove, okay, what is this? Okay, the 2 electrons, okay, you are going to get, sorry, O2 plus, this is the first one is O2 plus, O2 plus. If you remove 1 electron from the, okay, the oxygen molecule, then we are going to get a molecule O2 plus, thereby. So here, so when it is in the neutral condition, we have 10 electrons in the molecule, okay, bonding molecular orbital, and there are 6 electrons in the antibonding molecular orbital. When you remove 1 electron from that, then, okay, so only the thing is you have to replace this by 5. So above, okay, nitrogen, so this formula is fixed, that is 10 minus, okay, how many number of electrons, extra electrons are there, so all those electrons will come and occupy the, okay, what is that, antibonding molecular orbital, okay, antibonding molecular orbital, thereby, so what are the remaining electrons which are there, that is 5 electrons, okay, you can keep them in a, what is that, antibonding molecular orbital. Then if you substitute 5 here, and you are going to get the, okay, the bond order as, okay, 2.5. Then how to calculate this bond order for the O2 minus, O2 minus, thereby O2 only 1 minus charge is there. This is not O2 minus, this is O2 and only 1 minus charge, you can just imagine, thereby. So when we are going to get this, if you are going to add 1 electron to our, okay, neutral, what is this, oxygen, neutral oxygen, then we are going to get O2 minus, thereby 1 electron will be get increased with respect to the, okay, the neutral oxygen, thereby. So here we have 7, and then if you substitute and calculate the bond order, you are going to get it as 1.5. In the same way, if you are going to calculate for this, it is 1, thereby in which the bond order is highest. So we are finding, okay, the highest bond order in O2, okay, plus O2 plus O2 plus, and thereby the increasing order of, okay, the bond order, if you want to, okay, place them, then so here you just find the answer. Answer is D. that is O2 2 minus comes first. O2 2 minus comes first because, so what is the bond order we are finding for that? It is 1. Next comes to O2 minus. O2 minus, where you are finding the bond order is 1.5. Okay, and next comes O2, where you are finding the bond order is 2, and the highest bond order you can find in case of O2 plus, O2 plus, which is 2.5. Thereby the correct option is D, where the species are they are arranged in the increasing order of their bond order. Okay, so the answer is D. The fourth one. Now the shape of XCF6 is, they have given square planar, distorted octahedral, the third one square pyramidal and pyramidal. As I said, if you remember the shape of the orbitals, the particular molecules, then definitely directly you can mark the final answer, and so that you can save your time. So the solution is XeF6 molecule is having sp3d3 hybridized. After hybridization, XeF6 molecular geometry will be distorted octahedral or square bipyramidal due to the lone pair of electrons. So due to this lone pair of electron, otherwise it is octahedral only. So why it is distorted octahedral? Just due to the presence of this lone pair of electrons, our XeF6 is having distorted octahedral. Thereby the correct answer is the B. You have to mark it. Okay, now which of the following pair contains two lone pair of electrons on the central atom? So please read it carefully. Which of the following pair contains two lone pair of electrons on the central atom? So in order to know this, so you should be familiar with the Lewis structure for measure the molecules. If you know the Lewis structure, then definitely you can identify how many electrons are involved in the bond formation, that is the shared electron pairs, and how many electrons are not involved in the bond formation, which are called as a lone pair of electrons. So now let us see the molecular structure of the structures of I3 plus. So it is given as I3 plus and H2O minus. H2O. So why I have taken directly this? So if you gone through this, if I consider all the molecules, then it will be time consuming. That is why I'm just explaining. Just by looking into this, definitely you can see out of all these. Here water is having two lone pairs of electrons. And along with this, which you can place. So that's why I'll just give the molecular structure, Lewis structure for this. The correct option is I3 plus and water. So in this I3 plus, I3 plus, so there are three iodine, the atoms in this molecule. We are finding. So before it was not there. The structure was different. When you remove one electron from I3, then so this is a structure what you are going to get. So out of this structure, you can see that there are two lone pair of electrons over the central iodine, and thereby the even on the in the water molecule, there are two lone pairs which are present on the central atom, that is oxygen. Thereby the answer is going to be, so you just check with the others also. But when you have this water, definitely you can. But so how to match this? So that's why better to know the majority of the the structures for the measure the molecules which are there in your syllabus. If you know them, definitely without wasting time, you can give the answer for this particular question. So thereby the final answer is, what is that? The combination I3 plus and H2O, where you can find two lone pair of electrons on the central atom. Now the state of hybrid orbitals of, okay, carbon in carbon dioxide, okay, methane, and okay, CO3 2 minus carbonate ion. Okay, what is the, okay, the hybridization state? So what are the, okay, the options which are given? They are given like, okay, in the same order you have to find, okay, carbon dioxide, which is okay, hybridization, okay, methane, and also for the carbon, okay, carbonate ion. Okay, now options given are sp3, sp2, and sp, and the second option is sp3, sp, and sp2. Third option is sp, sp3, sp2, and the fourth one is sp2, sp3, and sp. Okay, now let us see the answer. Okay, as I said, so if you know the structures, and either or else if you know the, okay, the hybridization which is taking place, okay, definitely you can give the answer immediately. If not also, no problem. See, we know that carbon dioxide is having a linear structure, okay, which is a linear structure that indicates there is a sp hybrid, okay, hybridization it is there, okay. And whereas our, okay, the carbonate ion, okay, so in that our carbon is undergoing sp2 hybridization, okay, thereby it is having a trigonal planar structure. And methane, it is a well-known molecule, okay, so you have to remember, okay, which is having a tetrahedral structure, and where the carbon is undergoing sp3 hybridization, thereby, so which will be the correct answer? So carbon dioxide, as we said, it is undergoing sp hybridization, and our carbonate ion, which is undergoing, like here carbon is undergoing sp2 hybridization, and this is sp3. Then the correct answer is going to be, okay, which is the correct answer? The correct answer is, okay, C, because so methane is present as a second molecule here next the carbonate, thereby so carbon dioxide is sp, and methane is undergoing sp3 hybridization, whereas our carbonate, okay, it is having sp2 hybrid orbitals. Okay, the answer is now H2O2 is an oxidizing agent, a reducing agent. Both it acts as an oxidizing agent and reducing agent, neither oxidizing nor reducing. Okay, so I'll just go through this, okay, the sentences. H2O2 acts both oxidizing and reducing agent. This is the correct answer. Okay, so you have to give a clarification for this. Okay, oxygen of, okay, H2O2, okay, in this, it is having -1 oxidation state. In this hydrogen peroxide, usual oxidation number of oxygen, okay, remember students, it is -2. Oh, there are some exceptional cases where, okay, the oxidation state will be get deviated from -2, and one such example is in case of hydrogen peroxide. In this hydrogen peroxide, oxidation state of oxygen is -1. Okay, so if that is the case, okay, is reduced to water. See, if you are going to reduce this, okay, hydrogen peroxide to water, then our oxygen is undergoing reduction, that is from -1 to, okay, -2. That is the decrease in oxidation state. It is also called as a reduction. Remember students, while giving the definitions, okay, for the reduction and oxidation, I have mentioned there, okay, the decrease in oxidation state is also, you can also term it as a reduction process, where our oxygen, which is having -1 oxidation state, is get reduced to -2 oxidation state. That means that, okay, so it is helping for, what is that? Okay, the reduction. So now it is when it is helping for the reduction, so you can say that it is acting as a reducing agent. So next let us consider, okay, so, sorry, now in this case it is acting as an oxidizing agent, but itself it is get reduced when the oxygen of H2, okay, to -1, okay, is oxidized to, okay, O, that is 0, oxidized to, that is where the oxidation number state is 0, okay, acts as a reducing agent. Okay, thereby, so very clearly you can say that our hydrogen peroxide can act both as oxidizing agent as well as a reducing agent. So the answer is C. Now, which of the following structure, okay, which of the following, okay, structures of a molecule is expected to have, okay, 3 bond pairs and 1 lone pair of electrons? Okay, so which, okay, the structure is expecting, okay, 3 bond pairs and 1 lone pair? Okay, so you just see, the it is given that there are, okay, there is a total of 3 bond pairs and 1 lone pair. Total electron pair is found to be 4. So whether it is involved in bond formation or not, but the number of electron pairs you are finding on the central atom is found to be 4. So if you are finding 4, okay, the pairs of electrons, that says that it is undergoing sp3 hybridization. It is undergoing sp3 hybridization, okay. But out of 4, okay, the pairs of electrons, only 3 pairs are get involved in the bond formation and 1 pair, okay, is present over the, okay, the central atom, or the central atom. Thereby, okay, so the structure of this, okay, the structure of this is found to be, what is this? Pyramidal. Pyramidal. If there is no, okay, there are no, okay, what is this, lone pair? If all the, okay, the bond pairs are involved in the, okay, so all the, okay, the electron pairs are involved in the bond formation, then, okay, the structure is found, okay, regular structure is, okay, tetrahedral. Okay, it is a tetrahedral. But as of now, here, as we are finding 1 lone pair, okay, so this is having a pyramidal structure, and the best example you can remember for this is found to be, okay, ammonia, where we are finding 1 lone pair over the, okay, central atom, or the central atom. Okay, now, so what is the correct answer then? So C is the correct answer. Pyramidal is the answer. Okay. So if there are no lone, okay, the lone pairs, then the structure is actually tetrahedral. As you are finding lone pairs, the structure is pyramidal. Don't consider trigonal planar or octahedral. So you have to rule out, okay, these two options from this question. So that's why, as you know, okay. Now, which of the following compound of xenon has a pyramidal geometry? Okay, so the 4 options are given. So all are, okay, having a xenon, okay, in it. So which of the following is having a pyramidal geometry, and why it is so? So now you just look into the one by one. Okay, so the first molecule XeOF4, XeO F4, okay, F4, okay, and the second one is XeF2, XeF2. These are all lone pair of electrons, okay, and now here XeO lone pair, and XeF2 here is also lone pair. Now, just by looking into the structure, okay, looking into the structure, you can very easily, you can say that which is having a pyramidal structure, which is very similar to the structure of the ammonia. Just now we have seen that the structure of ammonia, which was also having a pyramidal structure. The same type of structure now we are finding for the, okay, XeO3, XeO3. Thereby, the answer for this question is, okay, C. It's, you can mark it. Okay, that's why I told you better to know, okay, the structures for each and every molecules, okay, which are there in a syllabus. So now, the ground state electronic configuration of nitrogen molecule is, okay, it is written as, so where KK, that is a K shell electronic configuration, inner shell, you need not to write. Only you can write the outer shell electronic configuration, which is having a sigma 1s2, okay, and sigma star 2s2, pi, okay, 2px2, pi 2py2, sigma 2pz2, okay. So this is the molecular electronic configuration of nitrogen molecule, okay. So if this is a electronic configuration, molecular electronic configuration for the nitrogen, where you are finding how many electrons in the nitrogen molecule. There are 14 electrons in the nitrogen molecule. Then the bond order of monovalent ion, that is N2 plus, is the bond order of N2 plus is where you are finding how many electrons now. Only 13 electrons is okay. So you have to calculate the bond order. Now in order to calculate bond order is equal to the 1/2 of the number of electrons present in the bonding molecular orbital minus number of electrons present in the anti-bonding molecular orbital. So I have not repeated the formula over here. So in this case, bond order can be calculated by using the formula, that is 1/2 of the number of electrons present in the bonding molecular orbital minus number of electrons present in the anti-bonding molecular orbital. Okay, now, so here, let us see, okay, how many electrons are here. So there are 7 electrons in the, what is this? Okay, this is the sigma, it indicates, okay, the bonding molecular orbital, 2 electrons, and count this 2 plus 2, 4, 4 plus 2, okay, 6, and 6 plus 2, 8 actually, in the outermost this is a 2, but we are calculating for a N2 plus, thereby 1 electron has been removed from the nitrogen, that is from the, okay, sigma 2pz, thereby if you remove 1 electron from here, the total number of electrons which are present in bonding molecular orbital is found to be not 8, it is 7, because you are calculating for N2 plus molecule, where we have removed 1 electron from this nitrogen. So before that there were 14 electrons, okay. Now once you remove 1 electron, it becomes 13, but we are considering only the, okay, valential electrons, and thereby, okay, instead of 8 electrons, you have to place 7 electrons as you have removed 1 electron from this nitrogen. Then how to calculate this number of electrons present in a anti-bonding molecular orbital. So if you go through this, only one, okay, anti-bonding molecular orbital you are finding here, that is sigma stars 2s, where there are 2 electrons are occupied, thereby -2, and the bond order is found to be 1.5. 1.5. If you calculate this, you are going to get the answer as 1.5. Okay. Okay. Sorry, 2.5. Okay, so you just calculate this. So 5 you are going to get this. I'm sorry for this. So this is actually not 1.5. You just make the correction. It is 2.5 because 7 minus 2 it is 5. 5 by 2 you are going to get it as, what is this? 2.5 is the answer. I'm very sorry for this. Okay. Out of the 4 planar molecules given below, which one has dipole moment equal to 0? Equal to 0. Cis of this particular molecule, okay, cis form, trans form of this, okay, and then, so actually this is actually, it is repeated over here, just don't consider, okay, CH2, okay, double bond CHCl, and CH2, okay, double bond CCl2, okay, CCl2. So here in this case, so dipole moment will be there for this molecule because they are not similar. Okay, you just take the half of this. Okay, this part is different and this part is different. Definitely you can expect the dipole moment over here and here also. Okay, here also, and even in the cis case also you can find a dipole moment. Only in this trans, okay, the form of this molecule, okay, thereby here